Good morning, grade 11s. We are now Tuesday, 26th of May. We have now finished the trig functions. We have done the graph interpretation, so we're going to have a quick look at what we have learned in grade 10, especially as we go through every lesson. Today we are going to focus on the ratios and the calculator work. Right, so the first thing you need to know about trig is that you need to know that sine, cos, and tan each has its own ratio. Sine is known to be opposites over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. Now, first of all, you need to know how to allocate this opposite, adjacent, and hypotenuse. So in grade 10, we taught you that if you do highlight the angle that you are working with, attached to it is the adjacent side. Opposite to that angle is my opposite side, and the longest side, or opposite the 90 degrees, you will find your hypotenuse. So when you do get coordinates, it means that OR will have a length of x, and PR will have a length of y. So when I want to write sine of theta, it's opposite, so it's y over, and that means the hypotenuse will be referred to as r, or I can write it as O over h. Cos theta is then going to be adjacent over hypotenuse, or I can say it's x over r. Tan of theta is O over a, so I can say it is y over x. It doesn't matter which one of these two you use. I use the O, H, and A version of it as we go along. Right. Now, we're not going to work in the first quadrant of a Cartesian plane the entire time, especially in grade 11. We almost don't want to work in the first quadrant. So if you are lost at this moment, if I have a Cartesian plane, that's my first quadrant, that's my second quadrant, that's my third quadrant, that's my fourth quadrant. Positive angles, we work anti-clockwise, so if I had to start my 0 anti-clockwise, I end up at 360 again. Right, so in grade 10 you learned as well that cost or all strippers takes cash. The boys in particular likes this version of it. Right, so what does that mean? All my functions are positive here. That means my sine, my cos, and my tan, all three of them works out to be positive. In my second quadrant, my sine works out to be positive. That means that my cos and my tan will work out to be negative. Why? Now let's add that. So if I had to add a line there and I created my right angle triangle, my hypotenuse will always be positive because trig happens in a circle. Okay, so my radius will always be positive. My y, so this is my angle, even though they do indicate theta outside, starting at the x, I use this angle to label my sides. That's my adjacent, that's my opposite, that's my hypotenuse. Now what do you notice? My y will be a plus value. My r, or my hypotenuse, is a plus value. But what do you notice about the x side? X will be negative because it's on the left hand side of my 0. So my a value will be negative. Right. If I move down into my third quadrant and I add a point that I can create a right angle triangle, I notice that my hypotenuse will always be a plus. They will indicate the angle starting at my x-axis. I'm going to use the inside there. That's my adjacent. This is my opposite. What do you notice now? The y value will also be negative now. So my opposite and adjacent will all both be negative, and O over A is a minus over a minus, which is a plus. Therefore, all my tan functions will be positive here, but my sine and my cos will have a minus over a plus, which ends up giving me a minus. If I go into my fourth quadrant, okay, angle will be indicated like that. I use the inside. That's my adjacent, that's my opposite, that's my hypotenuse. So my hypotenuse is always positive. My y-axis, well, my y value will be negative, and all of a sudden I have a positive x as well because it's going from 0 to the right. So if my a value is positive, I will have cos positive because a plus divided by a plus is a plus. But my sine and my tan will both be negative. Okay. So with this comes the ability to use Pythagoras. I will give you two sides. You will have to be able to work out the third side. We're going to do some examples just now. When you are allowed to use your calculators, please do all your calculations continuously and then write the final answer down. And very, 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 very important, your calculator needs to be in degree mode. Okay. Something that I haven't touched on, but you have done in grade 10. I just need to highlight one little thing here, is the reciprocals. So what is the reciprocal? It is the inverse, basically. So the reciprocal of sine is cosec. So where sine is O over H, cosec is H over O. In grade 11, they love to do this as well. So cosec is 1 over sine theta. Okay. Cos has a reciprocal and we call that sec, where cos is A over H, sec is H over A. Instead of using H over A, I can say sec is 1 over cos theta. Okay. Tan has a reciprocal of cot. Tan is O over A, therefore cot is A over O. Or I can say cot is 1 over tan theta. Right, so let's do some examples. So this statement, without the use of a calculator, in grade 10 it was used very seldom. You could have worked out all your trig with, or majority of your trig, using a calculator. I want to share the news with you now. In grade 11, 90% of your, maybe 95% of your work will be done without a calculator. Okay, so get used to that. Right, so let's look at trig ratio questions. So there's a few things that you need to understand. The moment I work with ratios goes hand in hand with a Cartesian plane. Okay, so they are telling me if tan A is 5 over 12. Okay, so they are saying to me tan A first of all, is plus. Okay, so if I draw my Cartesian plane, okay, I know I have that. So to have a positive tan, it will be either in the first quadrant or it will be in the third quadrant. So the second one and the fourth quadrant does not give me a positive tan. Okay, so how do I find out which one I'm going to use? I need a second restriction. They're telling me that A is less than 90. So from 0 to 90, that means I'm not allowed to use the first quadrant. Okay, so what are they giving me? They are saying to me that tan A is 5/12. Now 5/12 means my opposite side is 5, my adjacent side is 12. So hypotenuse, there's my A, there's my adjacent side, there's my opposite side. My opposite side is 5, my adjacent side is 12. They want me to work out sine, and sine is O/H. So I first of all need to work out the value of H. Using Pythagoras, H squared is 12 squared plus 5 squared. Remember to give recognition. I'm going to go out of stats or table mode. The square root of 12 squared plus 5 squared will give me the hypotenuse as a value of 13. Okay, so A, sine of A, I know is O/H. So that is 5/13. Cos squared A. So that means cos A is A/H. And that must be squared. So A is 12, H is 13, so it's 144/169. C, I have sine squared A plus cos squared A. So I have 5/13 squared plus 12/13 squared. That gives me 25/169 plus 144/169. That's 169/169, which is equal to 1. I want you to take a highlighter and highlight that. You will see later why. Okay, and then D asks for cot of A. Okay, so cot is the reciprocal of tan. If tan is O/A, cot is A/O. So that's 12/5. Right, let's look at the second example. Remember, you can pause the video at any time to do this. Okay, so determine the value of R and then write down the value of sine, cos, and tan of theta. Right, so first of all, I see that my x value is 3, my y value is -4. Can I work out the radius? Yes, I can. 3 squared plus -4 squared will give me the value, so I have square root. If you don't or not able to work it out, you get 5. At this stage, that would have been a natural answer, I hope. So, in terms of this angle here, that is my A, that is my O, that is my radius, and that's got an answer of 5. Okay, so sine theta is O/H, so it's -4/5. Cos theta is 3/5, and tan theta O/A minus 4 over 3. Very easy. Okay, then we come to the questions you hate. Right, so let's have a look at that. So if 5 cos theta equals 3, now at this stage you should have realized, and if that wasn't a hint enough, the instruction of work out using a calculator should have given you that this is a ratio question. And the moment you have a ratio question, you need to isolate sine, cos, and tan. So whichever it is, theta, alpha, whichever, because each one of them will have a fraction because it's got two sides in ratio. Okay, let's make that O over H, A over H, and O over A. So first of all, I need to say, hold on, you're not going to catch me out. So cos is 3 over 5, and I know that is A over H. So in my Cartesian plane, I know I am looking at a plus, a positive for cos, so it's either there or there. I'm not using quadrant 2 or quadrant 3. Where do I find the second restriction? They tell me tan must be less than 0. So tan less than 0 means negative. So I'm not allowed to use the first quadrant either because tan is positive there. I'm going to go in here. Right, so that's my adjacent side, this is my opposite side, that is my hypotenuse. Right, what do I know here? A is 3, H is 5. Can I work out the opposite side? Yes, I can. So 5 squared is equal to 3 squared plus, and that's going to be my y value. So the square root of 25 minus 9 is going to give me square root of 16, which means it's plus or minus 4. Which one will I use? It is below the x-axis, so therefore y will be a value of negative 4. So this is negative 4. So tan alpha O over A is minus 4 over 3. 2 sine theta, so 2 times O over H, minus 4 over 5, plus 3 times cos A over H, that's 3 over 5, is negative 8 over 5 plus 9 over 5. That's going to give me an answer of a fifth. Okay, so that is your lesson for today with your examples for today. So what are you going to do? You are going to do the homework, exercise 7.1 on page 180, those specific numbers, and exercise 7.2 on page 181, the first column in number 1. Have a nice day.